Welcome to Spaceverse, your portal to cosmic adventures. Some minerals in lava could suggest water is nearby. That may seem surprising at first. After all, lava and water seem like complete opposites. One is molten rock born from deep within a planet, the other the gentle liquid that makes life as we know it possible. But when they meet, especially during the cooling of lava, something incredible happens. That moment of contact can create unique minerals, and those minerals might be the very clues that tell us there's water here. Now imagine taking that idea and applying it to planets not in our own solar system, but dozens of light years away. Believe it or not, that's exactly what scientists are doing right now. One of the most promising ways to find water worlds beyond our solar system could involve looking for minerals in lava, specifically in cooled lava, on the surfaces of exoplanets. Here's the idea. If water comes into contact with fresh lava while it's cooling, it can spur the formation of specific minerals. And those minerals? They stick around. So even if the water itself disappears, the minerals remain as geological fingerprints. By finding those minerals, scientists might be able to detect signs of water, whether it's on the surface of an exoplanet or buried beneath it. Of course, this whole concept depends on a few assumptions. For one, some exoplanets would need to have had volcanic activity at some point. And not just any volcanic activity, we'd need lava flows that cooled and were later altered by water. But here's the encouraging part. This situation isn't just possible, it's actually very likely. Just look at our own solar system. We've seen lava flows on Mercury, Earth's moon, Mars, and even on Io, one of Jupiter's moons. That's 4 bodies with confirmed volcanic activity. And since these are all rocky worlds, it's not unreasonable to assume that many rocky exoplanets out there have also been volcanically active at some point in their history. That's why a team of researchers recently decided to dig deeper, and they didn't start by looking outward. Instead, they began right here on Earth. Their goal? To build a comprehensive database that could help scientists identify these water-altered minerals using one of the most powerful tools in astronomy, the James Webb Space Telescope, or JWST. They decided to focus on a particular kind of rock. Basalt? Basalt forms when lava erupts onto a planet's surface and cools. It's dark, dense, and fine-grained, and it's one of the most common types of volcanic rock in our solar system. It makes up vast areas of the ocean floor on Earth, covers the lunar maria on the Moon, coats wide plains on Mars, and even forms the surface of other planetary bodies. And it's probably just as widespread in other planetary systems. According to Esteban Gazel, an engineer at Cornell University and co-author of a study based on the basalt database, we know that the majority of exoplanets will produce basalts. Gazel explained that the chemical makeup of most stars that host exoplanets suggests that those planets are made of the right materials to form basaltic lava. It will be prevalent not only in our solar system, he said, but throughout the galaxy too. That makes basalt incredibly valuable, not just for geology, but for planetary science as a whole. But here's where things get even more exciting. Looking at a piece of basalt can tell us an amazing amount about its history. Specifically, it can reveal whether it interacted with liquid water as it cooled. On Earth, for instance, when water flows across newly formed basalt or filters into its cracks, it can form specific minerals like amphibole or serpentine. These minerals don't just sit there quietly. They actually interact with light in a very special way. Each mineral absorbs and emits energy at very specific wavelengths. Think of it like a chemical fingerprint, only written in light. This fingerprint is what scientists can use to identify different minerals, even across interstellar distances. And that's where the James Webb Space Telescope comes in. The JWST is designed to observe the universe in infrared light, making it perfect for detecting the thermal emission and spectral features of rocky exoplanet surfaces. Using its mid-infrared instrument, JWST can detect the light signatures from different minerals on distant planets, including those formed by lava and water interacting. So how does that work in practice? Well, Gazel and his team started by collecting 15 different samples of basalt from a range of environments here on Earth. Each sample contained a unique blend of minerals, some altered by water, others not. Then they used laboratory instruments to measure the spectral fingerprints of each sample. That gave them a rich dataset of how hydrated and non-hydrated basaltic minerals respond to infrared light. But they didn't stop there. Next, they used a simulation to figure out what these same spectral signals would look like if they were coming from the surface of a real exoplanet, specifically one called LHS-3844b. This planet orbits a star about 48 light-years away, and it's a rocky world, meaning it likely has a surface, possibly with volcanic history. That makes it an ideal test subject for the kind of mineral analysis scientists hope to do with JWST. By plugging their data into a model of LHS-3844b and imagining how its surface might reflect and emit light, the researchers could begin to explore what kinds of mineral signatures we might actually be able to detect from Earth's vantage point. According to their findings, by examining small differences in spectral features, scientists could, at least in theory, determine whether an exoplanet's surface basalt had interacted with water. In other words, even without seeing water directly, we could see the mineral evidence that water once flowed, seeped, or steamed across an alien world's surface. It's a brilliant example of indirect detection, using one kind of evidence, mineral fingerprints, to confirm the presence of another water. And that's exactly the kind of approach we need when exploring planets we'll probably never visit in person. But there's one big challenge left. Using the JWST to study an exoplanet's surface in this kind of detail would require a massive amount of telescope time, potentially dozens or even hundreds of hours. And that's a tall order. JWST time is one of the most valuable commodities in astronomy today. Scientists compete intensely to get just a few hours of observation time. Proposals are reviewed by panels, and only the most promising or time-sensitive projects get approved. Spending days pointing JWST at one planet to gather surface mineral data? That's going to be hard to justify right now. Still, the work has been done. The basalt spectral library exists. And when the opportunity finally comes to examine a promising target, perhaps LHS-3844b or another rocky world, the data will be ready. All the telescope needs is the green light. So what does this all mean? It means that lava, of all things, could be our path to discovering alien water, maybe even alien habitability. It means that even without direct images or samples, we can read the history of water in the rocks of another world, simply by decoding how those rocks shine and absorb light. And it means that some of the most ancient, most violent forces in planetary science, lava flows, volcanic eruptions, the slow seep of groundwater, could be the very signs we use to find life's most essential ingredient in the far reaches of space. So the next time you see a chunk of dark volcanic rock or a basalt cliff rising by the sea, think about the journey it tells. Think about how it cooled, how it cracked, how water once touched its surface and left a mark in mineral form. Then imagine that same story playing out 48 light-years away under an alien sky. And know that we're closer than ever to reading that story, one light spectrum at a time. And that's it. Thanks for joining us on this journey through lava, light, and distant worlds. If basalt can whisper the secrets of water across light years, imagine what else the universe is waiting to reveal. Stay curious, keep looking up, and don't forget to subscribe for more cosmic discoveries right here on Spaceverse.